Okay, problem number 48, page 87. All right, so we have this projectile. You're given delta y is 20 meters, time is 4 seconds to go from here to here, yf is 20 meters. Okay, so that's the vertical displacement. That's here. Theta f, this angle here is 60 degrees, and the acceleration due to gravity is given, or implied, negative 10 meters per second squared. And we're asked to find the horizontal displacement and the original velocity, which consists of the speed and the launch angle. Now, the first equation I started with is delta y is equal to VOY delta t plus 1/2 g delta t squared. I solve that for VOY, and I get delta y minus 1/2 g delta t squared, all divided by delta t. We know the time, we know the vertical displacement, and we know the acceleration due to gravity, so this will allow us to find VOY, the original velocity in the y. I take that value then, or this expression here, if you don't want to plug in numbers right away, and substitute it into this equation, which is a rearrangement of the equation for the definition of acceleration. And we can find the final velocity in the y, which is equal to the original velocity in the y plus the acceleration due to gravity times the time of flight. Once we find the final velocity in the y, we can go to the trig function tangent, and we can write that the tangent of the final angle is equal to the final velocity in the y divided by the velocity in the x. So we know VFY, but we don't know Vx. Okay. So what I did next is I solved for Vx, and I got VFY over the tangent of the final angle, omega f. So we know VFY, okay, so I can put that in here, and we know the angle, so we can get Vx, the velocity in the x. Knowing that, we can also find tangent theta original. That's equal to VOY, which we know, over Vx, which we know now. Solving for the original angle, we get the arctan of VOY over Vx. Now that we know theta original, we can find the original speed using the trigonometric function that Vx cosine theta is equal to Vx over VO. So VO is Vx over the cosine of theta. That will give us the original speed. And the horizontal displacement we can find using Vx times delta t. So that's the problem solved. So that was a challenging problem, and you notice how I basically used the kinematics equations for constant acceleration. I like to think of the equations as your guides to thinking, and as long as you write them down correctly and you apply them correctly, works like clockwork.